Hi everyone, welcome to another Frontend RheinMain live stream. My name is Katarzyna and I'm happy to be your host today together with Jose and Jan.
Hello, have a good day, good evening from wherever you are.
Please give a warm welcome to our speaker Gabriel and to Kevin.
Hi guys.
Hi guys.
Yeah, time flies so fast, and here in Europe, finally sunny springtime. Maybe not today, but yes, arrived, which is really wonderful. Yes, I think so. And what's the weather in Paris, Gabriel?
What's the weather?
Yes.
It's okay. It's not great, but it's okay for Paris.
Okay. Now, before we start, we would like to get to know our audience a bit. So, tell us, where are you watching from? You can write it in the chat. And who is watching us for the first time?
So I see there are 7 people currently watching on YouTube, and the number goes up all the time. So just write in the chat with a flag or name, where do you join today? And if it's the first time, you can also say it. We are always curious about our audience.
Yes, because we are really international. I'm originally from Poland, and Jan is...
I'm original from Germany and still in Germany, in Wiesbaden. So I'm not so that international like you, Katarzyna.
And Jose?
From Mexico, yes.
Yeah.
Really happy to be here in Germany. So.
And Kevin?
I'm from Hamburg, Germany. Nothing too special.
Wow, Hamburg is a little special. I heard it's a very beautiful city.
It is, but yeah, as you said, like spring lets us wait. So it's a very rainy day as usual here. So waiting for some sunny days.
And you, Gabriel, are you from?
So I'm from France. I'm French, and I live in Paris. And,
wow.
It's not super international on my side either.
Yeah, so it's a little romantic today by us. Okay, short shout out to all the new joiners today. Frontend RheinMain is a community hub based around Frankfurt. We are passionate to connect front-end developers, just like today. Yes, it's a few photos showing Brian. Take a look at our homepage, hit our subscribe button, and sign up to our newsletter. Yes, here's the map. It's next to Frankfurt. Yes. Thank you, Jan. And sign up to our newsletter, follow us on Twitter and meetup.com to stay connected with us and spread the word to your colleagues about us. Please, the next, we plan already the next event. The next event will take place on 12th May with Google developer expert Maxim Selnikov, and he will talk about automating service workers with Workbox. So save the date, please, and join us that day. And what else? By the way, we have some more plans for the future. So if you are searching for a side project to experiment with new front-end stuff and wanna contribute with ideas or something like that, then reach out to us. Also, we're always searching for interesting topics, so don't be shy to suggest one. Okay, so Jan, what's the topic today?
Yeah, the topic today is bringing pattern matching to TypeScript. So let me say a few words about this topic. I think we can maybe first answer a bit the question, what actually is pattern matching? And I was also a bit new to this topic. Also, I'm doing TypeScript, so I researched a bit, and quite a few times a quote from the Scala documentation came across me, saying that pattern matching tests whether a given value or a sequence of values has the shape defined by a pattern, and if it does, binds the variables in the patterns to the corresponding components of the value or the sequence of values. And so to now quote a bit also the abstract from Gabriel, with the emergence and by the adoption of libraries such as React, Redux, or XState in the last few years, the front-end ecosystem has shifted from an imperative to a declarative programming model. So, but TypeScript and JavaScript especially were not designed for this paradigm, if you know, and these languages are lacking a very important piece of the puzzle named declarative code branching. So Gabriel will demonstrate how we can write conditional logic that is easy to read and maintain using TS Pattern, his pattern matching library for TypeScript. And before I hand over to him, let us first thank Datadog. So Datadog is the sponsor of this event, and thanks for making this talk and the tempting cupcake raffle possible. We will do later in the WonderMe session, so please stay tuned after the talk and switch to the WonderMe session. We will post the link there. Datadog is a software as a service-based monitoring and security platform for infrastructure, application, logs, and more. And now I would give the stage to Kevin to show a few minutes a live demo of Datadog, what Datadog has to offer.
Okay, then let me share my screen. And
let me do this, and here we go.
Perfect. Thanks, Jan, for the introduction. Thanks, Kata. Yeah, as Jan already said, Datadog is a cloud monitoring offering. It's a SaaS product, and we're doing infrastructure monitoring, applications performance monitoring, logging, and of course, front-end monitoring. And to give you a quick overview about what exactly we are doing. So Datadog helps you to quickly connect all of your environment, be it backend or front-end environments, to a single unified platform. So if you have workloads running in AWS and Azure and GCP or on-premise, you can simply deploy our agents or use our agentless integrations to get all of this information into one place. The same is true for logs and traces, as well as front-end data, where we offer SDKs for browsers, for iOS and Android apps. All of this to have one unified platform. So a single pane of glass where you can look at your data and then correlate all of it to reduce the mean time of resolution, to find errors and resolve them as quickly as possible. In the middle, you can see that we are offering a lot of products. So we started with infrastructure monitoring, and then we went all the way to log monitoring, to applications performance monitoring, serverless monitoring, synthetics monitoring, part of the front-end monitoring, as well as real user monitoring. And in the next couple of minutes, I'm going to show you some examples about the front-end monitoring part. So let me jump right into Datadog. So what you can see here first is the numerous integrations that we maintain for you. So we have over 450 integrations into all the services that you are most likely using already today. So let's maybe pick the AWS integration here. And it is as easy as giving a read-only permissions from your AWS account to Datadog's AWS account, so that Datadog can then query the CloudWatch API, pull in the metrics, and within minutes after running a CloudFormation stack, you will then have all the metrics in Datadog from as many accounts as you want, and can then correlate all of this with, let's say, your Azure workloads. So connecting Azure and AWS is as simple as possible, and then you have a single unified view on your complete workloads running in the cloud. Let me quickly go into the host map to show you how something like this looks. So in this case, we can see that we are monitoring a lot of hosts. And if I type in a tag, cloud provider, I can slice and dice by the different cloud providers that we're monitoring right here. And you can see that we bring together Azure workloads, GCP, AWS, and then where it says no cloud provider, these are simply on-prem machines that we're also monitoring. Okay, so in the front-end part, UX monitoring, Datadog offers two things. So we differentiate between synthetics monitoring and the RAM applications. Synthetics monitoring being everything we can do from the outside. So API tests, talking about HTTP endpoint testing, testing your endpoints for 404s, for 500 server errors, and alerting you if any of those endpoints is not accessible. The second thing that we can do in the synthetics testing is browser testing. I will give you a short example of this. And then below that, you can see that we have the RAM application, which stands for real user monitoring. And this is where you deploy an SDK with your front-end applications to monitor them as well. Let me jump into the synthetics browser testing here. So right here, you can see a browser test that I have set up in Datadog. By the way, you can make all of these tests in Datadog part of your CI/CD pipeline. So in this case, such a browser test can be a blocking indicator for a Jenkins pipeline. So if this test fails, it will report a blocking status back to your pipeline, so you won't even roll out code that is not clickable. And how does such a browser test look like? So here I've defined a number of steps in an e-commerce store that we are hosting. And you can see here that it's marked which steps we take. So here we go into the chairs section, then we go into a product, we add the product to the cart, we go to the cart, then we add another product, etc., etc. So you get the idea. You define critical click paths on your front-end applications. And what Datadog then does is Datadog runs these exact click paths that you have defined from multiple regions all over the world in a time interval of 1 minute, 5 minutes, 10 minutes, and will notify you as soon as one of these click paths are not clickable. And this is then important for you, right? Because if Datadog cannot click them, your users cannot click them, and you're losing money and users here. And the cool thing is that we're not only telling you that something is wrong, we will also give you the opportunity to directly investigate what is wrong. So here you can see that I have a button which says one trace. And if I click it, it will bring up all of the information that we collect from your environment, be it front-end or back-end information, and it correlates all of this into this UI. So the cool thing is here that you now don't have to jump into different tools to find the metrics and the logs and the network information to troubleshoot what exactly went wrong. You have all of this correlated with this UI, which makes it super easy to you to understand if, let's say, this first step of the browser test fails, you can directly investigate what went wrong by looking into the metrics here. So all of the front-end metrics, as well as if I click on this Rails span here, the metrics from your host, as well as from your container. Alongside all of the infrastructure information, right? So you directly see which host, which Docker image, which container this was run on, alongside processes, network information, and then all the logs that have been thrown in this request. And this is made possible by injecting a trace ID in your logs, and then the Datadog UI can correlate this into this one single view. And by offering you this, Datadog allows you to automate the process of testing your front-end applications and then get alerted once something fails, and then have the possibility to directly jump into all the data that we have in the platform across your cloud providers, across your on-prem environments, to find out what exactly went wrong and to debug the issue and finally reduce the mean time to resolution. And by this having said, I would like to thank you for having a quick look at Datadog. Please jump to our platform, to our website at datadoghq.com and sign up for a trial if you like. You have 14 days of free trial. You can use the complete product. Give it a try. Let us know if you have any questions. Always happy to support. And with this being said, I'd like to hand over to my dear colleague Gabriel, who will talk about the pattern matching today. Thank you.
Okay, nice. Thank you, Kevin. Now, please use the chat to write your comments and questions about the talk, and we will try to answer them all. And what else? Like Jan said, we are pleased to invite you to meet us on WonderMe platform for Q&As, networking, and the surprising raffle, where you can win lovely cupcakes from Datadog, which will be delivered to your door. And keep your eyes on the chat. We'll drop the link there. And yes, okay, that's really enough. What I said now. Enjoy the evening, and Gabriel, the stage is yours.
Hey, can you all see my screen? Yeah.
Yes.
Okay, great. So, hi everybody. So I'm super excited to be here. I'm Gabriel Vergniaud. I work at Datadog as a database software engineer. And so by now you probably know everything about Datadog, thanks to the presentation of Kevin. You can find me on GitHub and on Twitter. And today I'd like to tell you about a very interesting concept called pattern matching, which I wish more front-end developers were familiar with. And so pattern matching is a way of writing declarative code branching. It's actually not that complicated, but it's implemented in a variety of languages, but it's not implemented in TypeScript and in JavaScript. And I think it's too bad because, in my opinion, pattern matching really makes us write code that is more readable and easier to maintain, update. And that's why around a year ago, I started working on a pattern matching library for TypeScript in my spare time called TS Pattern. And I really tried to focus on usability and type safety. And so during this talk, I try to make you familiar with the concept of pattern matching. And I'll give you a quick demo of the library I built, and I'll try to show you why I think it could improve a lot of the code we write every day in the front end. But in order to get there, I first need to give you a quick introduction and a quick overview of the front end ecosystem and the challenges we are facing today. So I start by saying that the front end ecosystem is becoming increasingly declarative. So the first big framework that really started talking about declarative programming for the front end was React. The goal of React is to make it easy to build UIs, and by using declarative programming, it showed us that it's much easier to actually declare what your UI should look like for a given state than imperatively manipulating the DOM directly to make it look like what you want it to look like. And this idea has really caught up in the front-end ecosystem. And today, a lot of other UI library aim to be declarative. And it's not only the UI library, a lot of state management library as well claim to be declarative. So what exactly does that mean? So the idea of declarative programming is actually pretty simple. It's the fact of splitting your logic into different steps. The first step is the declaration, and the idea is to describe what you want to happen by creating data structures. And the second step is the interpretation, where we write some code that will traverse these data structures to produce some side effects. So for instance, in React, we describe how the UI should look like using JSX. And then we let React interpret this description by going through the JSX template and actually mutating the DOM in a performant way. So your app-specific logic lives on the declarative side, and the app-agnostic one, the library, lives on the imperative interpreter. So why do we do that? So declarative programming has a number of benefits. The first one is that the code that we write is more concise, and that's because the repetitive part has been abstracted away inside the interpreter. Also, since the declaration is kind of a domain-restricted language, domain-specific language, the domain is restrained, and that means that there are fewer things we can do, and so there are fewer mistakes we can make, and that leads to less bugs. And another good side of declarative programming is that our business logic essentially becomes side effects free. And so that's great because it means that it's easier to test, it's easier to reason about it, to update it. And usually the performance trade-off, which is associated with splitting your logic into steps, is acceptable. But if I'm here today is to argue that there are a piece of the puzzle that we are still missing in the front-end ecosystem, and that's declarative code branching. And I think it's a big deal because code branching is an essential part of the complexity of the code we write every day. So what are the options we have in TypeScript today for code branching? So we actually have three options: the switch statement, the if and the else statement, and the ternary operator. So let's start with the switch statement. So I'm going to use React for my examples today because that's the framework I'm the most familiar with, but the ideas apply more broadly. So switch statement. So if you have used React, you probably noticed that using a switch statement inside React is not straightforward. You cannot use it inside of your JSX template like this. Or the only way to do that is to actually wrap your switch statement inside an immediately invoked function like this one. And that's because statements don't return any value. And since we are describing or like creating this description, we need values, and that's why statements is not really a good fit for a declarative context. What we need instead are expressions, which are pieces of code that does evaluate to values. Another downside of the switch statement is that you can only branch on a single value at a time. So here, for instance, I have this user object, this user type, which can either be anonymous or authenticated. And if it's authenticated, it's either an administrator or a contributor. And what I would like to do is to display some UI conditionally based on these two properties, on the type property and on the role property. But with a switch statement, since I can only look at a single property at a time, the only option I have is to nest switch statements together. And I still need to wrap them in this immediately invoked function. So that's not great. So what about the if and the else statement? So with them, we can check several values at the same time. This is the same example, but here our code branching is pretty flat. And that's because we can combine checks using Boolean operators like this. But it still doesn't fit super well in a declarative context. As you can see, we still need this function in order to put that here. And another issue I found to statements is that this kind of code tend to evolve badly over time. And that's because each statement is implicitly related to one another. So what I mean by that is that here I'm defining this JSX variable and then I'm conditionally assigning it. And nothing stops me from writing something completely unrelated in between these two statements. And so you might be thinking, why the hell would I do that? And the answer is that it's actually a bit more subtle than that. When you work on big code bases with a lot of collaborators, sometimes it's not super easy to see the intent of the code, and you just want to add something, to add some behavior, and you can write this kind of unrelated thing without noticing that you are breaking two different things that were related apart. And maybe later somebody needs to make an HTTP request if the user is authenticated, and he puts that here because that seems to make sense. But we end up with this complex code, which doesn't really reflect the initial intent, which was to conditionally assign a variable to a value. So that's not great. So luckily, we have another option. We have ternaries, which are expressions. So it's a concise way to conditionally assign a variable to something. And that's great because since it's a single block, we are less likely to add unrelated things inside of this block. So we'll probably end up with some code that looks like this, where each concern is separated, which is better. But the issue with ternaries is that they don't scale very well. When you need several branches, you need to nest your ternaries, and you have this kind of code that is not very easy to read. And there are other downsides, like it's hard to assign a variable. Actually, you cannot assign a variable inside one of your branch to reuse it because you are in this expression. And there is also another thing, is that I always need to return a value for the else case. And in this case, let's say a value.type is a known thing, and I know that it's either A, B, C, D, E, F, or G. I really don't want to have to return something in the other case, because I know that it's never going to happen. So what I would like instead is have TypeScript check that I'm handling all the cases properly, and yeah, I should not have to provide this new value. And so this concept of making the compiler enforce that we are handling all the possible cases is called exhaustiveness checking. There are several ways to do that in TypeScript, and here is one. So here you can see that we are defining this exhaustive function at the top of this file, and it doesn't do anything, but it takes a parameter of type never. Now, the never type in TypeScript is not something we can create with a value. It's actually a type that TypeScript will infer if a code path is unreachable. So here I have this fetch state object, and it can be either loading, success, or error. And since I'm handling all of these cases, TypeScript knows that the default case will never happen. So it will give the never type to this fetch state object, which means that I can pass it to the exhaustive function. And if I'm commenting one of the case out, so if I'm not handling everything, the fetch state type here will be the remaining case, which is error in this case. And I cannot pass that to my exhaustive function. So I basically made TypeScript tell me that I was not handling all the cases properly. So that's a very helpful trick, especially on big code bases with a lot of collaborators. But it only works with switch statements, and as we said earlier, it has a lot of downsides. So to sum up, we have no built-in option that is an expression that lets us branch on several values at a time, and that supports exhaustive checking. And that brings me to pattern matching. So pattern matching is essentially a way of writing declarative code branching. So it's a language feature, and it's implemented in a lot of languages. It's coming from functional programming languages like Haskell, Erlang, or Camel initially, but it's slowly making its way into mainstream languages like Rust or Swift or Elixir. And on the front end, we also have some languages that compile to JavaScript, like RustScript or PureScript, that support pattern matching. And so the big idea of pattern matching is that instead of converting the input data structure into a Boolean and using it inside the if statement, we are going to define the shape of the input that we want, and if the input matches this shape, then we will execute this branch of code. So this shape is called the pattern. And we actually have a proposal, a TC39 proposal to add pattern matching to TypeScript. So here is how it looks. So on the left, we have our usual if and else statements. On the right, we have the same code using pattern matching. So as you can see, the first thing you can notice that the pattern matching code is an expression. So you can assign it to a value. Here I'm assigning it to the JSX constant. So it starts with this case keyword, and then we give it the fetch state object. And we are going to pattern match on that. And then we have a bunch of branches, and they all start with this when keyword. So the first thing that follows the when keyword is the pattern. And so this is the shape we want the value to have to execute this branch. So here, if fetch state is an object with a status property, which is equal to loading, then we will execute and return whatever this branch returns. And if the status is success and we have data properties, then we are going to be able to use the data property inside of our code branch. So I feel like it's much more readable because it just looks like what you expect your value to be. So it's kind of hacking our natural ability to recognize patterns, which is really cool. But the downside is that unfortunately I don't think that it's going to land anytime soon. And I don't think that because this proposal is in a very early stage, even though it's been around for quite some time now. And that's because it's a complex proposal with a lot of interactions with other language features. And also, we might have it for JavaScript, but then we adding that to TypeScript will also be a big lift, in my opinion, because there are some type inference things that will need to be figured out. And that's why around a year ago, I started working on this side project called TS Pattern, which is a userland implementation for pattern matching, which tries to be as good as native language support in terms of usability and type safety. And when I started the project, I really didn't know if that was possible to do something that would be good enough. But in the end, I'm pretty satisfied with the result. So you can look it up on GitHub if you want. So here is the same code using TS pattern instead of the native language support. And as you can see, it's pretty similar. But the main difference is that we don't start with a keyword. We start with this match function, and we give it the value we want to match on, and then we chain a bunch of with methods. And they all take a pattern and a handler function that will be executed if the pattern matches. And it ends with this .exhaustive method, which does two different things. The first thing is that it will make TypeScript check that we are actually handling all the possible cases in our data structure to not have runtime error. And it's also going to execute the expression and return the actual value. So just to give you a quick intuition about what it looks like to be using patterns instead of the usual code we write. Here are some examples. So patterns can be literal values like strings, numbers, Boolean. And when you use that, it's equivalent to checking that your value is equal to the literal. And you can also, in TS pattern, you can put several patterns in with, and it essentially means that it's equivalent to using the OR Boolean operator. But patterns can be much more than that. They can also be objects or any data structure, actually. And if it's an object, I'm sorry. So if it's an object, we will check that the input value is also an object, and we'll check that each property inside the input matches the property on the pattern. So here it will match if the input is an object with a code property which is equal to 200, and a data property which is an object which has a type property which is equal to text. So it's equivalent to that code. It can also be an array of fixed length like this one, or a list pattern. So if you create an array and you put a single pattern inside of it, this pattern will be checked against every value inside of your input array in TS pattern. And the nice thing about patterns is that they can be nested. And they can be nested in any way and with any complexity. So it really means that you can use patterns for arbitrary complex cases. And as the cases are more and more complex, you can see that the code for pattern matching is much simpler than the equivalent Boolean logic. And here on this example, I'm also leaving out a lot of things that I'm actually checking with this pattern that I'm not checking here, like the fact that the first element is an object, the fact that the second element is an object, etc. So we also have special patterns, which are called wildcard patterns. And the most common one is this __ pattern, which always match, essentially. And it's useful when you are interested in a piece of your data structure, but you are not interested in another branch of your data structure. So in this case, if I want to match against any array where the second element is a 10 and which has a length of 2, then I can use this pattern, for instance. And there are also type-specific patterns like the __.string and .number, which will match if the name property is a string or the age property is a number. So this helper is exported by TS pattern. And so in the end, you get that kind of code where you can just put directly your match expression inside your JSX markup, and it just works. You don't need to wrap that inside a self-invoke function or anything. It's much cleaner. and you get exhaustive checking by default. So you don't have to write that. You can just write this instead, which I think is great. So now I'm going to switch to a quick demo to give you a bit more insight of how it is to be using TS pattern in practice. So so we are going to build a GIF fetcher application. So it's going to be a very tiny application, and here is the final result. So we'll have this this input, and if I type something, I get a list of GIFs, which I fetch from Giphy. So if I type dog, I get a list of dog, and that's pretty much it. So it's not super intimidating, and we'll see how we can write that using TS pattern. So let's have a look at the code. So the first thing we notice is that we have this state type, which is the type of the state of our application. And it has two different properties, the query property, which is a string, and the data property, which is a union, and it's either idle, loading, or success. And if it's in the success case, it has a list of GIFs, which is a list of strings, a list of URLs, actually. And there are also events that our application can handle. And we have three events at the moment. We have the search event, the success event, and the cancel event. So the search event is the one that is triggered when I type something in this input. And the success event is the one that is triggered when the HTTP request comes back and we have some data. And the cancel event is triggered when the import is cleared. So then we have this initial state, which is not super interesting. We have a reducer that doesn't do anything yet, so we are going to write it shortly. And then we have this component. And so let's have a look at the UI first. So it's very simple. We have this input, and every time the value changes, we are dispatching the search event with the content of the input as a query. And we are currently just displaying the JSON data directly inside our container. So let's, we also have this use effect hook, which is triggered every time the state .query changes. And it's going to, so currently it's not fetching anything, but it's going to fetch some data and return some results. And we are going to dispatch the success action when we get the result. So let's start by implementing this reducer. So as you have guessed, we are going to use this pattern for that. So we start by calling the match function on the event. The first thing I'm going to do is to end the expression with the .exhaustive function. And obviously it's not working, and TypeScript is telling me that I'm not handling all the cases. That's because I'm not handling any cases at the moment. So let's fix that by adding the first with method. So the first case we are going to handle is the search event. So as you can see, TypeScript is very helpful. It's providing me with some nice auto-completion when I write the pattern, which is great. And I'm going to define a handler, and I'm going to return a new state, which will have some query. So I'm going to update the query, which I get inside the event. And I'm going to assign data to loading status. Okay, and so the thing I need to do is that I need to extract the query property from my event. So how do I do that? So let's have a look at what we get inside the handler parameter. And we get an object with type search and a string query property. And that's actually the type of event which has been narrowed by our pattern. So basically, we get the same object, but the type is different, and the type is restricted to what the pattern actually permits. So here we have the query, so we can just extract it and use it in our handler. And that's nice, but we can see that TypeScript is still complaining, and that's because we're not handling all the cases. But it's not only complaining, it's also telling us what are the cases that are missing. And so here we are missing the success case and the cancel case. So let's fix that by adding some other branches. So on cancel, I'm just going to update the data and set it to idle. And on success, I'm going to extract the GIF URLs, and I'm going to set the state to success, and I'll pass the GIF URL here. So I'm also going to force the type to event and state. So this is the the input type of the match expression, and this is the output type of the match expression. I usually don't need to specify them, but in this case, it's better than having a big error, because if I specify them, TypeScript is able to tell me exactly what is going wrong. And what's going wrong is that I don't have any query variable in scope, so I just need to do that instead. We have a reducer, so let's have a look. So if I type something on the right side, you can see that I briefly am in the loading state, and then I'm in the success state. I clear the input, I return to the load state. It's what we want. So now let's update the DOM and display something more interesting than a JSON dump. So I'm going to match on state.data this time. And I'm calling exhaustive right away, and then I'll add some handler functions. So the first case I'm going to handle is the idle state. So it's status idle. And in this case, I'm going to I'm just going to return h1 with idle in it. That's it for now. And so, as we can see, our application doesn't compile yet. We also need to handle the other cases as usual. So let's add some branches for them. So in the loading state, I'm just going to display loading. And if I'm in the success state, I'm going to extract the GIF URLs, so using TypeScript auto-completion again. And I'm going to display fetch success. And I'll map over the list of URLs to return an image tag with our URL. So I also need to provide a key in React to avoid having some warnings, and I'll tag. And so here we are. So let's try it. If I type cat, I get a GIF of a cat, so that's great. And if I type dog, I still get a GIF of a cat, and that's because I didn't implement the data fetching logic yet. So you might have noticed that something that our application doesn't do yet is handling errors correctly. And that's not great, because if my promise rejects, let's say I'm rejecting with a new error saying, oh, my code doesn't handle that, so I get this big error message. So I need to do something. And what I need to do is to add a catch method here. And I'd like to display a new kind of, to dispatch, sorry, a new kind of event, which will be the error type. Currently it doesn't exist, but we are going to create it right now. So let's add a new error event in our list of events. Contain an error property. An error, right? And so the first thing we see is that TypeScript is not happy. We have our exhaustive method that is yelling at us, and that's because we are not in cases. As usual, I can just let TypeScript tell me what I need to do next. I just need to handle the error case, and what I'm going to do is to assign data to a new status, which is error. And it doesn't exist yet, so I also need to create it in the type. So it's simply the same object with status equal to error and an error, which is an error. And now it's the rendering match expression that doesn't compile. So let's add the code branch for the error case. In this case, we are going to display the error message in a p tag. It's not the greatest UI you have ever seen, but it works. So let's see if it actually works. And it does. So we can see that we are handling the fetch error properly. So now we are ready to switch to the actual Giphy API. So let's do that. So before the talk, I already prepared this search GIF function that doesn't do anything interesting except fetching some GIF URL from Giphy using a query. And so I'm just putting that here, and let's see if that works. So if I type cat, I get pictures of cats. And if I type dog, I get pictures of dogs. But as you can see, there is still a bug. While I'm typing, I get a lot of responses to queries I've made every time I made a keystroke. And that's not a great user experience. So one way to fix that is to cancel the previous promise. But here, I'm not going to do that. Instead, I'm going to handle that inside my reducer. And what I really want to do is to not switch to the success state or the error state if the success event is not the same, is not the event that corresponds to the query I have in my state, right? And so what I need to do is to first add a new query property, which will be a string, to the success and error events. And we are going to essentially use them as an ID to know what query this data is for. So we just do that, and here we need to set the query property. And now what I can do is I can make this pattern a bit more complex by checking the query property as well. So I want the query property of my event to be equal to state.query, right? And I want to do that for the error as well. So essentially what I'm saying is that the event must be of type success and has a query which is equal to state.query. And we see that our exhaustive method is yelling at us again, and that's because we are not handling every cases anymore. And that's right, that's correct. We are not handling all the success events where the query doesn't match. Let's handle them. So we could handle them just like we did before by just creating a new method and just returning the current state in this case, and the same thing for error. That would work. But we actually have a better option. We can use the __ pattern, which I presented in my talk, which matches anything. And we need to import it. And now we can see that our application compiles again. So actually, the exhaustive method is not super useful here because since I'm handling everything here, it can only be exhaustive. So since it's a pretty common case, there is a shorthand notation for that, which is the otherwise method. It's essentially doing what we were doing previously, but so now let's have a look. If I type hello there, you can see that I get a single result, which is much better, and I'm not having this UI that was flickering before. So that's great. And let's type something a bit longer, and you can see that if we have no result in the response, we end up in this state where we have this fetch success, but we cannot see anything. So what we would like to do instead is probably to display a no result message. So we could do that here by checking the array.length property. and using a ternary, and saying no result here, that will work fine, as you can see. But since we are using pattern matching, we don't need to nest several levels of code branching like this. We can do everything on the same level. Let's do that instead. We are just going to write a new branch. We're going to pattern match on the status success and give URLs equal to an empty list. In this case, I'm going to return no results. I'm not really using the array anymore, so I can remove it. And let's have a look at what happens. And it does work. So we have seen a lot of things. So let me sum up very quickly. So the first thing that we notice is that the pattern matching expression really fits well in the declarative context. We don't have to do anything special. We can just put our expression directly inside our JSX tag, which is nice. We have seen that exhaustive checking is really helpful, and it really helps us and guide us in the process of developing new features. We have seen that we can make complex patterns that check several values at the same time. And if I have still some time, I'd like to quickly show you another interesting thing you can do with pattern matching. So let's have a look at the search GIF function. And so let's see what it does. So it's essentially a wrapper around the fetch method that exists on the API. And we are just fetching some data from the Giphy API, the Giphy API, Giphy, I don't know. And so what I get in response is something of type any. So what that means that I actually don't know what this is. And so what I could do is to force cast it to the type I'm expecting, and that the documentation is telling me the API will return. But if the API changes, if a backend developer makes a change, then my code would be broken. So what I can do instead is that. So I can pattern match on this any value and check that it has this shape, which is what I'm expecting from the Giphy API. And then I can look at the value with the type narrowed to what my pattern permits. And I can see that I get the type of the pattern essentially. And here I can just write some type safe code and extract the list of URL out of the data object. And if my pattern doesn't match, I'm just going to throw that the pattern does not match. And that's great because since I'm handling the error explicitly, I know that my application is going to handle that correctly. So for instance, if I made a mistake and instead of images, I thought the API was going to return image, and I tried to search for pictures of cats, I end up with this error, which means that our application handles that gracefully. And if I change that back to images, I get back the list of images. So that's pretty much everything I wanted to show you during the demo. So let me get back to my slides. Yeah, so to sum up, yeah, I think that a lot of the complexity we write in our day-to-day life as front-end software engineers come from code branching. And I don't think we have the right set of tools to handle code branching properly. And I think that pattern matching is actually a great tool because it nudges us towards writing code that is safer, more readable, easier to update, to add new cases or to remove some. And so that's why I think that's great. And the TS pattern library is kind of my humble attempt to make this concept more mainstream in the TypeScript community. And so I released the version 3 of this library a few months ago, and it's the first long time supported version of the library. So feel free to use it and to send me feedbacks either on Twitter or on GitHub on opening issues. And if you want to have essentially the text version of this talk, you can Google bringing pattern matching to TypeScript, and you will probably find this blog post, which has essentially the same content as what I just told you. So thanks, thank you for your attention. You can find me on GitHub at gvernio and on Twitter at Gabriel Vernio. And that was it.
Cool. Thanks, Gabriel.
You're welcome.
It was awesome, I think, also for the audience. Really great talk. I like the live coding. This is always cool when you can demonstrate the concept more than on a theoretical way. Yeah, I think I need to dig into this really because I see that this solves a lot of problems of our daily TypeScript lives. What really impressed me spontaneously saying is that, yeah, the less lines of code are needed, while in parallel enhancing the readability and the safety. And this is really, yeah, it's really a cool thing.
Yeah, that's actually not a new idea, and
yeah.
that's funny that we don't have that in TypeScript yet, because it's really mainstream in a lot of languages, and it's much better.
Also, yeah, we have a nice feedback for you.
Thank you, Manuel. I'm glad you enjoyed it.
Yeah. Yeah, I'm curious. Maybe just the first question before we go all into the Q&A session in WonderMe, and also for the raffle. In the beginning, you mentioned that there are, if I remember correctly, thinkings in the TC39 committee about adding this pattern matching feature to ECMAScript.
Yep.
Right?
So there is this proposal which has changed recently. So you know how TC39 proposal work. So you have a champion, which is somebody that's going to try to make the specification adopt a new feature. And lately, I think the champions of this specific proposal have changed. And as a result, the syntax have changed also a bit. So I had to update my slides to take the update into account. And so currently it's still in stage 1. So there are 4 stages in the TC39 committee, like the way it works. And the first stage is essentially about seeing if there is if people are interested about it, and if that makes sense to be added to the language. And currently it's still in this stage, so the specific syntax has not been fully figured out yet, and might be changing in the future. And there is no formal specification to add pattern matching to the language yet, but I am hopeful it's going to come in the years to come.
Well, what is your feeling? How does your library maybe helps or supports these ideas? Did you get some nice feedback on your library already?
So I got some feedback, but not by the people working on the proposal. Mm-hmm. But it's starting to be used by more and more people. At the moment, there are around something like 15,000 downloads a month on NPM, which is not gigantic, but it's something. And people seems to enjoy it, but really it's just there because we are lacking native language support for it. And the day it's baked in the language, I don't think this library would be relevant anymore, and that's probably a good thing. But I'm not sure it's going to be tomorrow, so it's probably several years down the road.
Yeah, as usual in the specification world, takes a while. Yeah. So we also have a comment here. Made me realize I've forgotten to update my TypeScript version for ages. Gonna have a look at the library. Someone got motivated to update TypeScript. I think, well, what's the latest TypeScript version? I think 4.3 or something?
Yeah, I think that's 4.3, yeah.
Okay, cool. So I think we have, we take a final question with us here in this live stream, and all the rest we go then into WonderMe. So we posted a link already in the chat. Let me just show this question from Tristan. If you have considered Elm, as it does not allow null or undefined and forces you to consider all your cases.
Yeah, so I do have considered Elm, and another contender in that space is ResScript, which is also a language that compiles to JavaScript and which is a typed functional programming language, and it also has pattern matching. And I think both of these options are great, and I really like them. But the fact is that we do have a lot of TypeScript code today, and we have these huge code bases using TypeScript, and it's really hard to migrate them to new languages, because migrating to new languages has a cost, because everybody has to learn it. And that's why I think it's also helpful to have something that works in TypeScript, so that more and more people get used to these new ideas or old ideas, and so that more and more people are interested in those ideas and can try languages that support that as well.
Okay, thank you. Thank you very much. And I think it's time to go to WonderMe now, yes?
Yep.
Okay,
so
see
hope
you
you enjoyed it.
guys.
Yeah. See you in May for the next live stream. Stay tuned, follow us, and yeah, see you soon.
See you soon, and thank you all for joining us
Bye.
today. Bye-bye.
Yes.
Bye.